Hello everyone. In this semester, we are going to discuss, to talk about the data representation of data. This is an important course, an easy course. We are going to talk about the different data representations, take examples, and try to apply the main ideas and main concepts. So first of all, let's start with the basic concepts. Let's see some terms, some important terms like binary digit, like the word bit and byte. So in data representation, we always talk about these terms. دائما بدنا نشوف هدول التيرمز بهيدا الكورس. دائما بنحكي عن شيء اسمه بت، عن شيء اسمه بايت، عن شيء اسمه بشكل عام binary digit. شو يعني binary digit? Binary digit, so it's simply a number. And this number can have only two values. So it can adopt two values, either 0 or 1. So it's a number. يا بيكون هيدا النمبر 0 يا بيكون 1. It can represent various things, like, for example, true and false. So true, for example, is 1, false is 0, positive and negative, on and off. So either 1 or 0. We don't have other choices. هلا شو يعني bit؟ كلمة bit دائما نسمعها كلمة بايت. For example, لما نحكي عن الميموري of the mobile phone بنقول مثلا، أو لما نحكي عن الكاميرا بنقول مثلا هيدي الكاميرا 10 ميجا بايت or 20 megabyte, 1 megabyte. So what does byte means and what does bit mean? A bit, as definition, is binary information digit. So it refers to binary information digit. A bit is the smallest unit of information in computing. It was named by John Tukey in 1947. So a single bit represents one of two possible states, either 0 or 1. And it can convey up to one piece of information. So a binary digit can convey between 0 and 1 bit of information. This is the definition of bit. So also we talk about two possible states, either 0 or 1. Now, byte, the word byte, is a unit of digital information that typically consists of 8 bits. So كلمة bit، البت يا بتكون 0 يا بتكون 1. البايت، 1 byte comprises 8 bits, consists of 8 bits. So byte in general, it is the bit furthest to the, I can say that this byte is also used in computing, in many computer systems, in cameras, for example, and other devices. It is the smallest unit of memory that can be addressed in many computer systems. Bytes were introduced in 1960s. It became widely used in 1970s. It was used by Intel company, by Interprocessor. Originally, a byte was used to encode a text character, to encode the single character or text. This is the definition of byte. Now we will talk about the byte. We will see more information about the byte. So البايت هي 8 bits. A byte is equal to 8 bits. So here we can see an example. Here 1, 2, 3, 4, 5, 6, 7, 8. We have 8 cases, 8 bits. And each bit either has 0 value or 1 value. كل بت من هيدول يلي شايفين هون we have 8 bits. كل بت ممكن يكون فيها 1 ممكن يكون فيها 0. Now the most significant bit, this one, the most significant bit, this is the bit in a binary number that holds the highest value. So it's the bit furthest to the left, this one. It plays a big role in determining the overall size and in determining the value of the number. So if I take an example, so here, let's say here we have, for example, 0. Here we have 0, sorry. Here we have 0. This is the first bit. This bit is known as the LSB, the least significant bit. So this is the least significant bit. This is the bit in a binary number that holds the lowest value. So it's the best, it is the bit furthest to the right. The bit to the right. دائما على اليمين بنبلش من اليمين للشمال. على اليمين في عندي least significant bit. على الشمال آخر bit بنسميها most significant bit. So here if we have 0, 1, for example here, here we have another 0. Here we have 1, let's say. Here we have 0, 1, 0, 1. So here we have a byte. A byte includes 8 bits. We have 8 bits. This one is the least significant bit, and this one on the left is the most significant bit. Now, each binary digit, each bit represents a power of 2. So I mean here, أول bit, the least significant bit, the least significant bit, so it starts from the right with 2 power 0. So we start here with 2 power 0. The next is 2 power 1, then 2 power 2, then 2 power 3, and so on. So here 2 power 0 is 1. Yani least significant bit represents the number 1 in decimal. The second bit is 1. The second bit is 2 power 1. So 2 power 1 is 2. The third one is 2 power 2. Here we have 2 power 2. So this is 4. And then 2 power 3, 2 power 4, 2 power 5, 2 power 6, finally 2 power 7. Now let's add the numbers here. Let's this number 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. This number represents a binary number. This is a binary number. So if we want to convert this number, this binary number into decimal, what we can do, we look at the ones in this binary number. So here we have a 1, and here we have another one, a second one, here we have a third one, and here we have a 1 also. So we add now 2 power 1 plus 2 power 3. Here we have 2 power 3. 2 power 4, here 2 power 5. And finally 2 power 7. So we add 2 power 7 plus 2 power 5 plus 2 power 3 plus 2 power 1. We get the answer in decimal. So we get the answer in decimal. In this table, you can see the decimal numbers from 0 to 15. You can see the decimal numbers from 0 to 15. And you can see also their binary equivalent. So 0 in decimal is 0 in binary. 1 in decimal is 1 in binary. However, 2 in decimal is 0, 1 in binary. 3 in decimal is 1, 1 in binary. 4 in decimal is 0, 0, 1 in binary, and so on. So the binary system uses only two digits, 0 and 1. You can see here in the binary column we have just zeros and ones. ما بنشوف بالباينري نمبر بالباينري ريبريزنتيشن إلا 0 1 بينما بالديسيمال ممكن نشوف كل النمبرز. So here we have another example. We can convert this binary number into this binary representation, this binary number into decimal. You can apply the same concept seen in the previous slide to obtain the answer and to check whether this number in binary is equal to 33 in decimal, in base 10. So here 10 is the base. The decimal numbers represents the decimal numbers, base 10. However, a binary is represented by base 2. So when I say base 2, we talk about binary numbers. Base 10, I mean decimal numbers. So here you can apply the same concept. Here we can write 2 power 0, for example. Then here we have 2 power 1, 2 power 2, 2 power 3, 2 power 4. We look at the ones only. And finally 2 power 5. So if we add these values, 2 power 0, so 1 plus 2 power 1 is 2, 2 power 4 is 16, and 2 power 5 is 32. If we add these values, so 32 plus 16 is 48, 51. The answer should be 51, not 33. Not 33, so 51. This is another example if we want to convert from binary to decimal. We have a binary number 10101. If we convert it into decimal, if we convert it into decimal, so we apply the same principle, the same concept, we obtain 21. We obtain 21. 21 in decimal. So 21 in decimal is 10101 in binary. If we put all 8 bits 1, so the 8 bits are 1, 1, 1, 1, 1, 1, 1, 1. So if we add all these ones, we obtain 255. A number system. Let's talk now about the number systems. A number system is a way of representing numbers. So when I say number system, this is a way, a method to represent numbers. Each system is based on a base, or what's called a radix also. A base or radix determine how many possible digits can be used in that system. So it determines the number of possible digits, how many possible digits can be used in that system. So the base tells you how many unique digits are available. For example, if the base is R, let's say our base is base R. R could be 0, 1, 2, 3, and so on. So if the base is R, then there are R digits ranging from 0 to R minus 1. يعني مثلا إذا أخذنا الديسيمال base is base 10. So a decimal system, this is the system we use in everyday life. It uses 10 digits. 10 digits ranges from 0 to R minus 1. I mean from 0 to 10 minus 1, that is from 0 to 9. So the 10 digits, we use 10 digits in base 10 from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The value of each position is a power of 10. هلا الفاليو بالبيز 2 بالباينري بالبيز 2 the value of each position is a power of 2. However, in base 10, in the decimal base, the value of each position is a power of 10. We have also other types, other systems. We can talk about the octal system, as you see here in the figure. This diagram shows the different types of number systems and their corresponding bases. So we have the decimal system. This is base 10. We have values that range. The ranges of the values are from 0 to 9. We can talk about the binary system. We have just two values, 0 and 1. This is base 2. The octal system is base 8. Octal system يعني base 8. It uses digits from 0 to 7 only. So in base 8, we can just represent numbers or represent any number with values from 0 to 7 only. And we have the hexadecimal system. This is base 16. The hexadecimal system uses digits from 0 to 9 plus letters from A to F. A, B, C, D, E, and F. So F in hexadecimal is equal to 15 in decimal system in base 10. Hexadecimal is often used in programming and computing because it can compactly represent binary numbers. So it's preferred to use hexadecimal numbers in programming and in computing systems. So let's talk now about the representation of data. We need to mention the computers. Computers store and process data using bits, using binary digits, and each bit can have one of two values, 0 or 1. So this system can represent also more complex data. Can represent a number, a character, an image, or any other type of data. So we have a fixed number of bits which should be used to represent different types of data, like numbers and characters. If you have n bit storage location, if you have n bits, you can represent 2 power n distinct entities. For example, with 1 bit, you have or you can represent 2 distinct values, 0 or 1. So this is 2 power 1. 2 power 1, that means we have 2 entities, either 0 or 1. We have 2 distinct values. With 2 bits, we have 2 power 2 distinct values. So we have four different values, four distinct values, which are 0, 0, 0, 1, 1, 0, and 1, 1. However, with the 3-bit memory location, we can store one of 8 possible binary patterns. We talk here about 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So we have 8 possible binary patterns. So 3 bits can represent 2 power 3, I mean 8 distinct values. This idea is important and fundamental in computers to store different types of information. Whether this information is a number, is a character, or is any type of data.